Uh, Hello everyone, welcome teacher. This is our presentation about machine learning projects for recognized. Our team has three members, me, Thành and Khai. Our talk include six parts. First, introduction, workflow, data preparation, SVM model, average model, conclusion, and future plan. Uh, First, face recognition, also known as the facial recognition, is one of the popular applications of artificial intelligence, in which computers are used to automatically identify and classify human face from images or videos. Face recognition projects typically and involves developing a system that can accurately detect and recognize human face from webcam. The process consists of collecting and labeling a medium dataset of facial image, training a machine learning model to recognize face, and optimizing the model for accuracy and speed. For this instance of time, ML model is FVM, while optimizers are determined by research CV.
Okay, so to get to our goal, we have this workflow. So for you to easy understand our project, first we take photos of our faces and then label them. Our facial image has the shape of 400, 403. Then we processes our, then we process it by OpenCV to have the to convert it into array images with the shape of 400, 400, 403. The first 400 means for faces with each person has 100 images. After that, we extract the picture and put them in the SVM model. In this part, we choose best parameters for training and to to train evaluate model, and if the model not good enough, we go back to the choose best parameters part and then until it is better and save model. And after all of that, we deploy our model into real life. So how did we collect the photos? Well, we use OpenCV for collecting photos images. Our data include four faces, Đông, Khải, Quân, and Thành, with 100 images for each person. And to avoid noise as much as possible, we have set the rectangle on the display for the people who put their face in it, as you can see here in figure 2. And after that, we normalize dataset by dividing by 255 to get the figure 3 preprocessed data. Mm, the Because we avoid noise as much as possible, so the data will have less noises affected by background or brightness. We normalize them to have better distribution. We split the data into 80% for training and 20% for validation. The datasets have four classes and belong to four people, like I said before. And PCI, with by using PCI, so we can we can see the distribution of our dataset like this figure 5 in 3D and figure 6 in 2D.
Look at the distribution, we can see SVM can solve problem very well. Now go to explain SVM model. It have three important parameter: margin, kernel, regularization parameter. This margin is a separation between many classes in core margin. This is margin formula. Next, kernel represent the shape of separation line. The more suitable kernel is more accuracy we have. And this the formula. Regularization parameter is C in inversely proportional to strength of the regularization. By using recursivity of scalar module, we can select best parameter for our model. C equal to 0.01, kernel is linear. C equal to 0.1, kernel is linear. Before deploying model in real time, we will go to the model evaluation step. Looking at the classification parameter and a confusion matrix, we can see that model work very well. All parameter is equal to 1. This is very well to deploy in real time. To confirm performance of SVM, we compare it to some other model. Here is the result. Here's result of test data. It's worked very well. And now we can deploy in real time. Last, this is our conclusion and future plan. Our data and model work pretty well in real time, and the problem only stop at the level of classification, but this is a good foundation for learning and implementing our big project later in the future. Our plans is upgrade problem to detection and classification in real time, and hope to be able to put into widespread use in practice. Thank everybody to listening and watching.